Hello, everyone. A very good afternoon. I would like to thank you all for joining us today. My name is Aparna, and I'll be hosting this webinar. Before we get started, please let me take a few minutes to introduce Payatu. We are a research powered cybersecurity consulting firm with a decade long track record with a singular focus on cybersecurity. Our foundation rests upon three pillars: community and conferences, consulting and training, products. Community and conferences encompass Nullcon, an international security conference training and exhibition platform, and Hardware.io, a hardware security focused conference along with other initiatives. Consulting and training focuses on thorough security assessments, which helps businesses to discover security threats and further provide training to strengthen network infrastructure. Lastly, we have four offerings: IoT Auditor, an IoT security testing and compliance platform; Exploity, an open source IoT security testing framework; our Exploity Academy is a comprehensive online learning platform that empowers professionals with the knowledge and necessary skills to excel in the field of cybersecurity, particularly in the context of securing IoT devices. Cloud First, an automated and highly scalable first testing platform. Here is an overview of the various consulting assessments we are known for across the globe. We have delivered many cyber talks and workshops in top security conferences that also include Black Hat and DEF CON. We take pride in the decade-long impact we have created by contributing in the cybersecurity community all around the world. As part of our ongoing commitment to fostering knowledge sharing and collaboration in the cybersecurity realm, Payatu has launched an exciting initiative, the Payatu WhatsApp community. The community aims to educate various organizations with industry specific cybersecurity content. For those curious about hiring, these are our recent openings. You can apply through the links sent in the chat box. That was all about Payatu. Today, Ajay, Payatu's security researcher, will deliver a webinar on race conditions. You can read all about him on this slide. Before I hand it over to Ajay, I request you all to follow a few housekeeping tips. Please be on mute. If you have a question, you can write it in the chat box. We'll answer the question at the end of the webinar. We will be releasing the recording of this webinar on our digital channel, so make sure you are following Payatu. If you are not currently following Payatu, please check the links provided in the chat box to find Payatu's digital channels. Without further ado, let's get started. Ajay, over to you.
Hi, I'm Ajay. Today I'm going to take about the topic racing against time, decoding and exploiting race conditions. So let's start it. So what is the agenda of this webinar? So I'll be talking about what is race conditions. You'll be getting an understanding of process and threads. I'll be telling about different types of race condition, which is race condition that occurs in memory and race condition that occurs in file system. And then I will be telling you about some Posix thread programming concepts, P threads. Then I will be telling you about what is critical section and mutual exclusion logs. And I'll show you an race-free code and also a code that suffers from race conditions. So you could go through both of them and see, okay, what code makes it suffer from race conditions. And finally, a practical exploitation of race conditions. What are the key takeaways of this webinar? You will be getting an in-depth understanding of process and threats and a secure coding aspect in multi-threaded environment. And finally, you will be able to spot race condition source code review and learn how to exploit race condition. The third point, which is understanding and spotting race condition source code review, is the main part because I have seen experienced web application pen testers who have a lot of experience in exploiting race conditions, who have done n number of findings on race conditions and everything. But when I ask them okay, so how do you find race conditions? They say I just bombard a lot of requests, and if there is something it's an offer coupon, so it's like a 40% offer coupon. So if I use it twice, or if it triggering twice, we may give it 80%. So it's a race conditions, and I'll be like, okay, that's good, but what makes it suffer from this? What is the code behind that made it suffer from this condition? I have seen a lot of people, when I ask them, they don't know about it, they get stuck on that part. Then I told them so bombarding requests is risk condition. We're like, kinda, but so it's basically when people say it, it basically falls under they can't do it dynamically. They can do it dynamically, but not statically. It always falls as like race conditions can only be found in dynamic application security testing, but not at SAS. So here in this webinar, I will be telling the in-depth concepts about race conditions. So when you guys go through it, you can be like, okay, so this is how race condition occurs. So there is this mutual exclusion concept, and there is this threat concept, global shared resource, and everything is there. So we have to keep in mind. So how to hunt for race condition, how to view an application when there is a global shared resources in place. So let's start about telling about myself. I am Ajay SK. I am IoT firm security researcher at Payatu, and I am a part-time CTF player who loves to solve binary exploitation reverse engineering challenge. Most of my profile until Payatu was like solving CTS and binary exploitation, and that made up my whole of my knowledge in security and everything. So I love playing CTS, and I'm experienced in pen testing the client application on various platforms. So it's not always like Linux and Windows. I have done Mac application penetration, Mac application pen testing as well. And I got an yellow belt at College, and I secured multiple top position in various CTF events. I'm trying to get green and blue belt right now. I'm very active at College, and I'm very not at learning low level programming stuff that C assembly stuff, and also memory corruption bugs that happens when proper memory safety implementation has been done in C applications. So C and C++ applications. So yeah. So what is race conditions? So this is a normal definition. Like I will read through it though. Race condition occurs in computer program when the outcome depends upon unpredictable timing or order of concurrent events. So even I could complete it, but let's leave it there. So it basically say it's like unpredictable timing order of concurrent events. So this is mostly the definition what you can see in college books, what you ask a developer, like everyone they say this. So, but what is race conditions like? So when most of the people get asked this question, they throw this definition and be like, so from college students to highly experienced individuals and developers, pen testers, and everyone says this definition. So what basically it is? So we have this meme, so let's get something from it. Like developers, when they develop a multi-threaded application, so a life of gambling always comes with it. Actually, whenever a developer writes a multi-threaded application, so he when he doesn't implement those some codes like logs, semaphores, and everything, he actually makes a gamble. Like this is how it usually happens. So I will go with the best case scenario, but most of the people doesn't solve the worst case scenario. And the reason why the people don't solve the worst case scenario is race conditions are harder to find. Race conditions are harder to get triggered. Even for seasoned pen testers, race conditions to get triggered, like of 100 iteration get triggered once. So for n number of like request or n number of even for an race condition that occurs in binary applications, it get triggered once. So most of the time it's a best case scenario. So people don't view that part, but always the worst case scenario gets triggered at least at one point of time. Even it's harder to find when you run when you run to try to run some fuzzers, or when you try to run some testing kind of thing, stress testing or anything, it still tries to escape. Race conditions are the bugs that are super harder to find. Even fuzzing with even like pen testers or any zero-day researchers who try to fuzz it, it's harder to find race conditions. It's super hard. So yeah, peeps, I get it. So you guys will be basically thinking like this. So what is this guy even speaking about? So race conditions. So what is race conditions? He's talking about seasoned pen testers, and he's seasoned developers, and he threw this term called multi-threaded application, and there is a lot of terms he threw up. So what did he basically say? So stay with me now. So what I will be telling you all this. So let's start up with what is a process? A process instance of running program. The This meeting you have been seeing in Zoom. is also a process. And Google Chrome when you used to watch YouTube and when you study something and everything, when you sprung up a terminal, when you use MS Paint, when you use Microsoft Word, everything is a process in systems. You take Windows, Linux, IoT devices, everything. When you run up a program, it's basically a process. It has a lot of things at their disposal. They have their own memory, they have global variables, they have shared libraries in them, they have everything. So let's take a process as a context of this guy who's standing here. He's a very happy person. He's working in a factory. He's a single person taking care of the factory. Everything seems nice. Productivity is kind of low because he's the person who takes care of this. But productivity is nice. He's happy with his job. The superiors are happy with his job. He does it well. There's no errors that's been taken up until the factory falls up. We don't get anything. Like he's not doing anything messed up. So it is fine, everything. So take this person as the process, a process. The factory is a process, and he is a person who is there. Take shared libraries or some machinery. When you put the raw materials, you would get some raw materials, you get a product, or take it as a shared library. So Python, you use Python, and C we use libc libraries, use thread libraries, use math libraries to solve something. So take those as shared libraries, and you have a place to put all these products and all these raw materials. Take the first storage areas, heap and stack, wherein dynamic memory allocation, dynamically memory allocated will be there, and in stack where statically located memory, where you in CUs like integer, local, 10 and everything, those will be in stack. And where also you declare global variables, where it will be stored in global context dot data dot bss. Yeah, I get it. Like most of the concepts I'll be saying is new, but let's go through it and I will show you all of this. So this is a process. So what happened? This is this virtual memory. Take this concept as factory context again. The Take this whole virtual memory. Virtual memory is like the memory that's a projection of your memory in your system. Take this as a city and process context as factory. So we have the city and we have 1, 2, 3, 4, 5 factories. We have it here. So every factory has a single worker. The work has been done good, but there is some issues. Like we have this thing called IPC, inter-process communication, like in system. So even that context can be applied here. So if you want to transport your materials from one factory to other, you need a driver, you need a truck, you need to keep it safely while moving all this and everything. So that's the place where IPC comes up, and it's a bit costly. It is costly because like setting up a factory is costly, setting up this truck and carrying this work material is costly. So process costly. So you may be thinking like, why set up if all the factories have been same? Why set up a single worker on every point of it? You can set up multiple workers in a factory, and conjointly they could work together. So that is the place where you'll be getting threats. But there is this factory again. But what we have been seeing is those guys are about to fight each other. Like the supervisor is trying to fight with the co-worker, and worker is like grabbing the supervisor by his neck. So this is the thing that happens in multi-threaded scenarios. Like it is messed up. It is totally messed up. So, but here the setup cost and initial cost and everything is less. So so we have a factory, we have multiple workers here, we get a really good production, but the thing is they have to be synchronized. So because what happens is they are trying to access same mission, same products, same raw materials and everything. So when they don't do it in a synchronized way, it falls up in a very messy way. So that's what happens. So thread is a short for thread for execution. It represents sequence on the CPU will execute to remember how to return from function calls and everything. So it's an definition again. So this is that threat scenario. Like these guys are like I want it, like I want this resource. Like how can you take my resource that was supposed to be mine? So they are basically fighting with each other, and this fighting happens in our systems as well when the synchronization hasn't been done good, when the virtual exclusion locks hasn't been applied well, when semaphores has been applied well. These are the some multi-threaded concepts that I'll be saying at the end of the talk. But so these concept, like try to remember this concept will come up at the end. So you'll so when I say this, it's not a new thing when you go over it. So let's see how threads look like in systems. So this is how threads look like. Like we got a process, we got this main thread is that single worker, but we have two threads here. Like in process 3, you can see that there are two people working on it. But the thing is, like when you want to transport anything in between main thread and thread 2, it is very simple. It is super simple. In system, we use global memory, and in factory we use basically have a separate space where both of them can access it. So instead of moving a lorry for transporting something, we got very simple here. We got a really good production. We got a really good production. We have an increased production rate and everything. So that's how it basically happens. But what is the downside of it? The downside is when they are not synchronized, they basically fight with each other. And the supposed production that has to be at the level of process is very less than that. So what happens is you get an increased overhead and also decreased production when it has not been set up well. So let's go to so these are the difference between process and I will get back to it, but let's go to see how process and threads actually work in a practical way so you can able to understand it. So yeah, guys, so we let's start up with process. We have cat process.c. Well, that's not a hard C program. It is basically very simple. So what happens is it basically prints out the process ID and the parent process ID of the process. So parent process basically think like headquarters of the factory, and parent process like the address of the normal factory. The normal process ID is that address of the factory, and parent process ID is the address of the address of the headquarters of the factory or the main branch of the factory. You could say about it like this. So let me execute this. You'll basically get like 7845 is the process ID and 7332 is the parent process ID. So if you want to, I was basically saying there are this memory and everything. So let's see, there are some multiple file handles. We got file descriptors. We have separate lot of things for this. So let's look. This process is an easy way, and also in a way like nerdy kind of people look at it. So it will be I'll be putting in a GNU debugger, and for this I'll be putting in a normal I will be seeing in a proc maps. So let's go to 7532. So let's see what 7532 has. Let's change it to that directory. Let's see the contents. We have a lot of things. So let's go to maps. So it might be a bit overwhelming, but this is the process that was running as bash because this bash shell started up that process. So that's it's a bash process. We have the heap, the dynamic memory allocation part, what I was saying. We have the shared libraries, which I was telling about, the libc, libmath, everything. We have the loader for the program. We have the stack where statically allocated memory will be located. We have vwhere, vdsovs is called. These are a bit complicated things, so I won't be going through it. But yeah, this is the memory mapping of the process. So take this memory mapping as the location of the places. Like I told you, like star heap and stack is the maybe a production place or any place where you keep all those raw materials or products. So take this is the address where it has been kept. Maybe a room number or something you could take that context as well. So this is how it, and this bash is the address of the guy who's been working. So yeah, take a bit. You could take in that context. So we have FD. So this FD has the file descriptors of the open files. We have COMM, which basically say which command it was. You could see the command line. It was basically bash. You can see the environ variables of this. Then you can go to task, which is basically a threads we are talking about. And this is how basically goes. You can go for mounts. These are the file system mounts. So yeah, there are a lot of things. So this is one way you could look upon it. So this is how you can look up at your process. And there are a lot of things. So when you run ls, you can basically see what are all present in this process. You can see memory, you can see a lot of this. Just remember this, there is this output. I will show you something right after this part. This is an easy way to look at what is processes. So when you could go inside it, you can see what is this process. When you go to command line, you can say it's a bash process. Basically this terminal is the bash process that started up. This is that parent id. Then you can see what is the login id of this, your the permission of the user that started up this. Then you can go art status, which mostly won't get populated sometimes. Then you go to IU, what how many characters are getting readed and how many characters are written and everything. Then you have this syscall thing, which mostly it's a protected file. You need permissions to access this. You could view it using cdcat syscalls here. We have a lot here. Like if you want to look at very easily, like when people go startup, you want to look at it all of this easily. It is you can look from here. Then there is this other thing as well. You want to see what is in present in the process stack. This is the backtrace of the process, like when it's running. As you can see, we have a lot here. So for this, if you want to look up at a process information, you could go here, look a lot of information from here. You have cat status, which prints a lot of contents. You can basically go to chat gpt and put this contents, and you could verify like what are all these contents and everything. So if you want to look at in a nerdy way what are all this process and everything, which I will elaborate for sure, because I want people to know about what happens inside the process. So I spawned up something called a GDB, basically called as GNU debugger. So what I'm going to do is I'm going to run this process inside this. So this is a debugger. What it basically does is it allows you to inspect what's happening inside. It can allow you to write something if you want to change something inside the process. If you have a GDB access even on some process that you want to change, it could be any protected file, or it could be any protected process, like maybe a game that asks for a key. You could basically bypass the check using this. If you really become good at better at reverse engineering, you can know how to crack games, softwares, and everything. A lot of this happens. People used to do this. This is basically goes under this, going under this process, researching what's happening inside it. So let me do something called info functions to print what are all the functions here. We have a main function, which is basically this. Let's keep a breakpoint here, run it. You can see a lot of output here. You can basically see, okay, what's happening? Like there are a lot of output here. I need to understand what's going on. So the first thing is called registers. Basically, these are the components that used to reside super near to CPU. So the accesses are pretty fast. So when you access something, we have cache and everything, right? Register is the one that is very close to the process. So when you access something, it puts inside it to process and everything. We have a lot of registers depending upon your architecture. If it's 32-bit, if it's a 64-bit, if it's a different architecture, ARM 64, we have a lot here. Depending upon the architecture, all of this registers changes as well. So what we are seeing here, then we have our disassembled code. This is, so when you see this, I can basically see, but you can get confused. But what is this? We have this get ppid here, get pid here, printf here. When you go here, you can see the same thing in C, but what happens when you compile the program, it changes into binary. And CPU, the binary is basically these instructions encoded inside it. So what happens is CPU basically execute these instructions. It won't execute the C code you give, because C code can't be understood by your CPU. CPU only understands binary, and this zeros are are ordered in a particular way that construct these instructions. So what happens here? So these are the instructions of the program that's written. This is called stack. This is the place where all your local variables reside. So when you see like a local variable, like if you like put up something like a is equal to 10, a is equal to 20 inside a like you like in simple program, you guys know it, right? So int a is equal to 10 inside a function block, it's local variable, but when it's kept outside the function block, it's not local variable. All the functions can access it. That is because when you run a function, all the local variables or everything used to reside inside the stack. And when the function gets completed, it pops out every one of this. So you can't able to access this. So even when you try to write like a local variable outside it, the program doesn't know how to figure it, because it's not part of the function block it has been created. So that's the reason even memory is unreachable. So that's why your compiler basically will throw error that basically says like there is an issue, we can't access this memory. But global variables we can access it because it doesn't resides in this place. And this is this call stack as well. When you run it, it basically doesn't start with your main function. It goes through a lot of this function to set up then execution environment for main. So so what happens is it basically does this instruction, it pushed to something, then it reduced some stack space. You can see d8, it subtracted rsp by 2. So this is called subtract. So what happened was, before executing this, you can see that it is e0. Then after pushing it, it went t8, and then a subtract happened, then it become d0. So when the program completes executing, like when it all happens, you can see that it went back. When the ret instruction was about to happen, it went back to the e8 again. And before that, you can see d0 is again. You can basically see what happened was, when it finished all the execution part again, you get the same memory before running this. So it started with e0, and it, before the leave and everything happened, it went to d0 and e8 again. So when it's about to finish, it removes everything from the program. So yeah, so this is a node way to look up. When I run the maps here, you saw this stuff, right? This is called process memory mapping. This is the place where the bash process resides. The stack I told you, right? This is where the stack is, where the local variables get stored, and this is the place for the global variables getting stored. Then C program basically uses a thing called malloc, free and everything. When you do malloc and free, it doesn't get stored in the stack. It does dynamically get stored in something called as heap. So this is that place. This is the libraries I told about. The analogy which I gave you was tools. These are the tools like use it for processing and everything. We have this libc. We have all of this. This is the one that loads it, loads the process, basically the one who constructs the factory kind of thing, you could say, basically who started up all of this. These are all the things. So the information you look in these files are the same information you can basically look from here as well. This is a bit nerdy way to look at. Like if you want to play around with the process and everything, you can look it from here. If you have an asm understanding, you can look up from here as well, or else you could look at from here. It basically boils basically down to your point of curiosity, like you want to understand process in this way or that way. And I showed you this thing called FD, right? The file descriptors and everything. This is the place of the file descriptors, where all the if you open a file, this is the place where it get comes up and everything. So a nerdy, this is a general way to look at your process, a nerdy way to look at your process. So these are the, so as I am like super interested on this low level programming stuff and memory corruption, I basically use this to look at more often. So let's go back. So this is what processes. Then there is this other thing called threads. So I can't like leave you hanging without showing us some code on threads as well. So I should do it right. So you can basically see the difference. So process code is very less, but the thread code is very huge. I get it. Understanding this is piece of cake, but understanding this is gonna be harder. But I will basically make it very easy for you to understand. Just leave these header files. I have included all of this to run these functions. Basically think these header files as everything that are required to run these functions and everything that has the definition for these function, so compiler can know where to take the code and everything. So we have so I will give you a code walkthrough here. We have a global string which basically says I can be accessed by both thread like the num value above me. Then there is other global variable that basically says is equal to 1. And let's go from the main function. I told you, right, there is this thing called heap, which performs the dynamic memory allocation, which keeps the storage place for dynamic memory allocation. So what I'm going to do is I'm going to allocate 100 bytes. So this function inside it, this argument inside it basically says how many bytes I want to create, want to have. There is this 100 bytes. Then what I'm going to do is like the cat process ID we did, like this get PID. What we are going to do is using get PID we are going to get the thread ID. So basically it's like the worker's address, not the factory's address. So we have this process ID as well as this thread ID as well. Then we have then we are printing this. What we are going to do is we are basically going to print this process and thread information, basically the thread ID and the process ID. Then what I'm going to basically do is print the value of the global variable, which will print 1. Then I will proceed to do something like then I will print this. I can be actually both thread like this one again. Then this part, it is hard to understand. So I will basically say this. What happens is I'm basically creating a thread, basically assigning a new worker and I told him to do this job, basically execute this function part. So what this other thread will do, thread I told you there is this main thread and thread 2, right? So thread 2 will execute this rather than executing this main function. So thread 1 will main thread will execute this because that's what the name is. Main function will be executed by main thread, and thread 2 will execute this thread main as well. So what happen, then I will sleep for a few seconds. Basically I'm telling the main thread main worker to basically, bro, let's have some sleep. Then I change this value to 1. Then I will wait until this worker finishes his job. Then I will just return from this program. So let's go back here. What does the main thread do? It does the same part. It basically mallocs this memory, do the same thing like most of the things like this thing from here. Basically it's the same thing from here until this. Then I do something called as a check. I'm checking whether global num is double equal to 1. Basically like I'm telling whether this is the as a factory worker analogy, I'm basically checking, is this the quality of material, is the product is the product is having, like we have a way to check the uh, products quality, right? So I'm checking whether this variable is equal to 1. That's take that as an analogy, and basically what I'm doing is I basically check global num is equal to 1. If the global 1 is not equal to 1, this part won't be executed because it has to go through this. It checks from here. If the value is not same, it will not execute this. So if it executes this, basically the value would be global num equal to 1. So you can ask me, so value of global num is 1. I have printed it out already. Why do you want to do it again? There is a catch in it. So that catch will be, I will be showing it afterwards. So let's run this process. Let's run this binary and see what's happening. So first what happened was main thread executed. It basically said this is the my process id and the thread id is same because it's the main thread. The value is 1. Then I can be accessed by both thread like the num value above me. So this is a global variable. Basically both of them can access it. You can see puts global num and global star are not declared inside this function, declared inside thread main or main. It is declared outside the function. So people who are very new to computers, you can basically I said you right, the stack and the global variable part. So the some of these global variables can access by both of this. So which basically makes it a shared resource here. It's not always the files. You can see the shared resource as the global variables as well. So both of the threads are accessing at the same time. So what happened? Let's see this. Then the second thread started up. It gave its thread id, which is basically different than the thread id from the process. We have the same thread id and process id here, but this is different. This is 13091 and this is 13092. So thread 2 is having a different id than thread 1, which is basically different workers have different id for them. So the value of global num is 1. I can be asked by it prints out like the same, but the value of global num after sleep is 2. Like value of global num after sleep is, it should be 1. It should be 1. Basically it should be 1, right? Because if global num is equal to 1 is given, then when it comes here it should be 1, right? But it isn't. So it is a race window that's happening here because this thread is updating the value which is used by this thread as well. They have kept a check and everything, which is basically time of check and time of use here. Time of check, when during the time of check it was 1, during the time of use it wasn't 1, it is 2 here. So that's why when it printed, it passed the check but it printed it's 2 here. So now let's, in a nerdy way, let's do something again. And before that, let's go in a general way. We execute it again, we get this 13187, right? This process. So we go to 13187. Then let's go to this directory. There is this directory called task. Mostly for a single threaded process it used to be same, but for multi-threaded process you have two things, 13187 and 13188. This task is the one directory that changes according to your this one directory that changes according to your multiple threads. So process, like the same directory it used to be same, but inside the task it used to change. So when you go inside this, you can see the same type of directory like proc as well. So for we have 13188, but basically this process ended, that's why it's not showing anything. So this is the same way to look at thread as well. If you want to, if you basically think like, okay, I can look at this for process, but what happens if a thread has different file handles and everything? If what happens if it has different has file handles, different memory pages and everything, you can look at from here as well. Inside the task you can look at what are the difference like both of the threads have. So let's go to the nerdy way again. We do the info functions again, but we are not breaking at the main here. We are going to break at thread main here. So let's run this. So we have other thing this time. It's like we have a different thing called threads to total. When you do info threads, we can see this one is executing nano sleep and this one is thread main. So let's and we are in thread 2, not thread 1 here, because we break that thread 1, right? So when then there is this other thing as well. So you can basically see when you do xinfo, basically what I did was I passed this address, which is the stack pointer address here. We get a different memory page. What happens when you do xinfo is when you give a memory address to it, it basically prints out where the memory address is and which place it resides and everything. But when you go to thread 1, I do the same RSP here. You can see this process. Like even you could do this. You could copy this thing and you could put this. So both of them doesn't have the same stack. Main thread has its stack here, but when you go to thread 2, thread 2 actually finished executing here. That's why it stopped. So let me do it again. So I do it again. When you do this thing, xinfo RSP is different than xinfo. Go to thread 1 and do the same thing. It's going to be different memory space as well. We return back to thread. Then when we do this, execute the see the heap. When you want to see your dynamic memory allocation and everything, where you put this, I can be accessed by both memory and everything here. When you do this, you can see it is in heap. But when you do that when you run the same heap chunk command in here, there are no arena found or anything, because thread I think thread 2 did complete executed, I guess. So it finished actually. When you run the malloc again, let's see the heap. It is a different address here, right? What I basically want to say is different threads, it's different threads have different stack and heaps. They have their own memory regions. Main thread access this as a heap and this as a stack, but the second thread which we created it as a second worker has this as the heap, and his RSP is different. He has stack as here. So they have different heap and stacks as well. So you need to look up at this as well. So what happens is they basically create an isolation as well. So like basically two factory workers have different bags for them. They have their lunch in a different bag and everything. You can see this is basically that. But you basically want to know, let's search where is this I can be access part. There is this string, right? I can. So when you see it is here. So let's see where memory location it is. You can see it is present in home striker race. So basically what is it is present in this binary itself. So why is it present in binary? So the thing is like, for allowing it to access to by everyone, it is keeping it is in a global resource. So it basically kept in the binary and basically say when you want to access here, don't look up at stack and heap. I have it in this place, take it and use it everyone. So as this place is not isolated, we have an isolated stack, we have an isolated heap, we have an isolated place for memory allocations and everything, but this is used by both of them, right? So what happens if one writes it and one reads it? So it is basically what we call as a global resource here, which is accessed by both of them. So the reason why this, even after the check it came, was when you go through the source code a bit, you can understand that this updated it, because this thread has access to this as well, and this thread has access to this as well. This isn't much harmful, but this is a bit of what we call as talk to here, time of check and time of use. This is a small race condition that happened in memory when a developer developed it, which is basically me here. I basically thought like, okay, global variable is the check goes and see it's one, then it should be one here, and I used it here. Basically I thought like, it not gonna change or something because I placed the check and I didn't and I used it as well. But there is a small 2 seconds that happened here. In this 2 seconds, this one changes. This is what called as race conditions, unordered time of events. So one went a bit ahead, one went a bit backward. So if anyone asks what is race condition is, when two things try to access the global resource at the same time, both made changes to it or both access the variable and used it. Basically, if I see a lot of web application security researchers here, so if they let's think as a hamper code or anything, offer code, coupon code or anything, you put it, what happens is when I see people, they basically using intruder or anything, they just try to use the same coupon code again and again. And if it was a one use code and it happens to be get used twice or thrice, it is a race condition there. But what happens inside the code is that what happens is a database handle is used, like let's go in Spring or Java framework or anything. You basically have a database handle for every route. What happens is they have something called a slash update for every API routes. Like let's make it as slash update or crud basically, because remove this or update this or anything. What happens is basically one thread accesses a different API route and one thread happens to access the same API route. Or even if it's the same API route, what happens is there is this one thread that basically want to say, I need this coupon code and it hasn't used thrice. This coupon code is global variable. It checks it. Both of the thread has access to it, and both will go and see it. Okay, this hasn't been used yet. I will use it. But what happens is the two requests that happened there. One request went and checked it, and other request got checked at the same time. So when both of the check that happened at the same time, the check basically said like, okay, it hasn't been used yet, and you use it, but it was used by one thread at a single nanosecond or single microsecond. It was used, but before the check was supposed to say it wasn't used, both of them used it because both of them can access it at the same time. There was no atomic operation that one should access it at this point. They haven't created something called as locks here or atomic operations here. So what happened was two people basically said, I want this coupon code, and basically used it. Or a single person using the same coupon code twice or anything. So when people ask like how race conditions happen, basically it's like accessing the same shared resource again and again, same ratio at the very same time. So people, so I seen this person who basically said at a database point, both of them get checked out at the same time. So at the checkout part, what happened in code was the same database handle was used at the same time, updated it, and basically said okay, it was one at the same time for both of them, and it got checked out and basically said yeah, it is good to go. So let's get back to the slides again. So so if what is threats and process from your understanding, can I ask it? So if people want to go vague about it, you can go vague on here, or also a simple definition could be fine, so I can able to know like my knowledge, my things has been reached well. Any chat box messages? Okay, I will come to here finally. So let's go back to the slides again. So this is the difference between process. Creating a factory and creating assigning a worker is different. So but there's a memory isolation and separate kind of thing here. Both of them share memory here. That we saw this using the global memory, global variable context here. But for this we need something called as IPC to do this. Yeah, basically if you want to create a process, a lot of things gets initialized at the thing, but for threads it's not. Complicated to access shared memory because IPC is hard. Easy to access shared memory because global memory is global variables or anything is easy. Memory isolation is makes it secure, and global variable makes it less secure but easy to access. So there are a bit of trade-offs here. So when you engineer an application, you need to look at and think, if I need threads for doing it fast and with very less resource, I can do it, but I have to do it really good, or else I would be suffering a lot of race conditions here. If you have a lot of resource and you don't care about the memory constraints or like initialization constraints or everything, you can go for processing and everything. So there is this thing called race conditions in file system, because it's not only the global variables that suffers from race conditions, it's also the file system, because file system is also a what we call as global resource, because one process can access the file system again and other process can do it at the same time again. So let's have a small I have created a small example for it. You have this thing called filetrace.c. It's a bit big file, but I will basically boil down to it's very simple. What happens is you have to give two arguments. It checks whether the file can be only read by root. If it only read by root, it won't execute it, but because it will say sorry, can't read root files. But if if the file doesn't belong to root, it will basically print out your content. So when you run file race and do something, we have a thread.c, right? When you do it, it basically prints all of this, but it only prints 100 bytes, so you're not getting most of the contents here. So this is a set UID program. So when it executes in the root permission, but it won't allow you to read or write read root files. So they have kept it root, but they don't want you to allow you to read root files means. But what happens, like, I pass this check, but at this point, when this check basically says like you are fine to go, it's not a root file. But when it was about to open this, I will open a root file. So let's see. So I have created other file as well. This file, what it basically do is it basically renames both of this file. So what I'm going to do is I'm gonna create a file called vim.a, write some stuff here, basically garbage data. Then I'm going to do what is called a symlink. Then what I'm going to do is create a symbolic link. Basically, I'm gonna give the symbolic link as this file and point it to this thing. So let's run this file racer thing. Sometimes it won't start and run at the very start. You won't like get the file contents and everything. Why do I choose flag 2? Because when you go to flag 2, it can only be read by root. So as this program has the ability to open the root files, we can use it to read this file as well. When you try to use cat b, it basically says permission denied. So I want to read this file. So let's run this program, which basically is an exploit for this. What it basically do is it renames the file a and b simultaneously again. It just exchanges the file names again and again. So let's see what happens when you do something like this. You run this file trace thing again with a with b. Okay. So you get it right. So when I run this, what the program run was the user ID of the owner of the file is 1000, which is basically not, because this file belongs to root. But this file also says, but it worked. So at most of the points, but some of the times it can basically say, sorry, can't read root files because the file is 0. So what happens is when you do it, ls-la, you can see b points to flag 2. Then both of them doesn't point to it. Then when you change according to it, like values getting changed here again and again, like a points to flag 2 at one point. So basically what this thing does is it exchanges the files and again. So this is a classic scenario of race conditions. So a talk to check, it checked it, it said basically you are good to go. Then when it was about to open the file, it wasn't, because the file contents got changed and it pointed to the root file, so it opened and print out the file contents. When we try to open normally use the cat b, it didn't work because permission was denied. But when I do it, sometimes it gets the contents of a. But when I do it with here, I get this. Sometimes I don't get it. So some of the times it fails, some of the time it prints the contents of a. So this is what happens. So basically what here it happens is both process are fighting, like I want to see, let me take that argument and parse it, and let me take a, let me take this symlink. So what happens is basically these two processes are fighting, and during that a small window this happened and we were able to get it. So as file system is a shared resource between processes, memory is a shared resource between threads. So of course, race condition in memory is rampant and multi-threaded programs. You can basically see what happened in the last program. When I basically did it, it was supposed to print one, but it print two. There is this meme as well. Today I had a problem to solve, and looking at it, I thought I know how to do this. I will use threads. Then he used threads, and you can see what happened. Execution event got messed up. Now he wrote, now I too have problems and everything. But don't come to a conclusion like, okay, let me I don't need to know complex locking mechanisms or some mechanism to reduce race conditions. I will just code it in single threaded way. You can't, because single threaded has some race condition if you use signal handlers as well. So there is a signal handler. When you use control C or anything, it passes signals to your program. So what happens if you use a signal handler like this, but that signal handler has operating system will operate it. Basically think signal handler as an outside audit worker or any person who comes to audit your office, and he does some messed up shit on your place, and he basically says like, sorry, we did this. So the thing is, you shouldn't have an global resource for him to access as well, even though you are a single threaded. So that's what it is. Race conditions in memory are present not only multi-threaded, it's also in single threaded as well, where single signal functions are used. There is this concept called non-reentrant. You should look upon this concept, like how to code it non-reentrant way. And there are some library functions as well called str token c, which is not thread safe because it uses a global variable as well. You can look on this on man pages. If I go to man pages, I can basically show you. I'll clear the screen. You can basically see at end of this my example should basically say empty, not yeah, empty and safe race, because it uses a global variable to use something. So they gave a caution, a big caution when using this function. If you do use them, note that these function modify the first one. Not only this, you have to be careful because it uses a global variable. So you have to be careful while handling this because it is not thread safe. But str talk underscore r is thread safe. So you need to use while be careful. Then basically, when you ask me, race condition simplifier, does that mean race condition basically boil down to the meaning of accessing shared resource in a non-synchronized way? The answer is yes. And they also mean the developers who develop the application made assumption about the global resource, because when the check was done, basically the file trace program basically thought like, yeah, this is good, like there isn't an issue here, because when the program was solved, because I checked it, it's not a root file, but it finally read the root file it wasn't supposed to read. So that's what happened. There was a slight conflict in it. So that was the race condition. Is it is basically a conflict that happened between accessing a global resource. The answer is yes again. So basically, if you want to know about race condition in a meme way, it's like siblings fighting over inheritance property. Like I want the house constructed by dad, and that was the same house fighting by this other sibling as well. He's also saying like I want it as well. So there, and in computer you can basically say two or more processor threads trying to access the same global resource. So corporate wants you to find the difference between those picture, and they are the same picture. So This is some Posix thread API. If you want to learn how to code threads in C, you can use these threads. You can go to Posix thread and do this, create that. So these are the one of this has been used in our program, Posix thread create and join. You can learn it using man space pthread create pthread join and everything. Then we have two examples. I told you I will be showing you examples of a race free code and not race free code here, right? So let's see. I have this program. So it's a global variable. We have threads here. So basically we are accessing a global variable here, race condition maybe. But here we are doing the same thing, but we have something called as mutex lock here, and it is a bit different. So we are doing. Let's run this program and see what results we get. Yeah, the classic race condition program suffered, and we can see it was supposed to be the program was supposed to end and give this result. It gave this. One of them was this. One of them was this, and the file at the time it was executing by the time it was spent on executing was this much. But there was this program with this something called as mutex log, and it finished pretty quick. And you can see the value of sum and everything here has been pretty good, and no error was there. So is there a way to mitigate race conditions? And yeah, it is like you could see what basically mutex log does is it basically stands outside the code, outside the door. And if you so basically if you go to a party or anything, there are like bodyguards standing. They basically say there are already a lot of people inside this place, wait for some time. Then after the people comes out, they were like, okay, there are some places have been freed, so you can get inside. So, and there is this other thing called critical section, which is basically a section of code that should be only executed by thread at one time, which is the global resource access part. So those are the parts. So when you see this program, this is the critical section part, which should be accessed by thread at this only one time. Where here you can see to protect this critical section, what we did was we had a mutex lock. We basically protected it, saying, okay, let's wait for here. Let's only allow a single person to use it, and when the single person exits here, when your other thread try to access it, it would basically say no, the value already has been this much. So yeah, it is finished. So there was no error here when you use this. So this is what mutual exclusion is. We basically says mutual exclusion, or you take your time, I will wait, and then I will proceed to go inside. So you have to code this one also pretty in a good way, because there are some chances for something called as deadlocks used to arise. So plan it out well. So yeah, then there is this thing golden rules for dynamic memory allocation. So I'm gonna have this. I'm gonna show you a practical, and so I'm gonna show you a program that is vulnerable. But when you see that program in a single-threaded way, it is never vulnerable, but it is vulnerable in a multi-threaded way in a multi-threaded environment. So let's see what happened when it was accessed in a multi-threaded way. So yeah, it is going to come to an end. So let's go here, and this is that program. We have a program here. So we have this program called baby prime level 9.1. I have opened this program in a Ghidra, which basically decompiles and disassembles your binary. So what it basically does is it gives you welcome, it opens a socket, it waits for you at the 1337 port. So when I go here, when I run it like baby prime, it basically wait for a TCP port here. So this was actually a vulnerable challenge. It's like for labs, you could say. So what happens is it creates a P thread. For every connection, it creates a thread. You could see here bind, listen, socket, and everything. Then there is this accept. What it basically is, when you connect it, you have been create a new thread has been created, and this ren thread would execute. So what happens is it basically opens the file called flag file, and this is this challenge actually. So in this challenge, you can basically see what is like happening as I'm not going through the source code or anything really well. This is a global resource. But if you want to access a global resource, you need to have this thing called lock, right? Like lock, the last time I said it, like when you need to use a global resource, you need to have locks and everything. So what happens is, if locks is not there, so sometimes two of the thread access at the same time, it puts in a pretty hard way. So what happened is, let's do some memory race conditions here. So there are some heap rules we have. You can see, do not read or write to a pointer returned by malloc after the pointer has been freed. So when we go back, we can basically see free. What it basically does is, when you do a malloc thing here, when you do something, when you do a malloc part here, it gives a dynamic memory address for you. It basically mallocs it, and it will put it here. Then it will put in this memory address. Separate this is a global variable as well. Race condition again. Then when you attempt to free it, it frees it and nulls it as well. So you don't have an use after free scenario here. Then do not use or leak initialized data. Then they are reading it really well. Like when you try to see here, scanf, they read it only until the size they have been allocated. So only the size, only the 1024 size is being used, and they will check whether the size is like matches it and everything. So they are doing pretty securely. When you take all these heap rules and see, you won't see any invalid free heap underflow, double free heap overflow. This is a really good binary that has been written with a really good engineering, that in a single threaded environment, if it's in a single threaded environment, none of the exploitation being done. 1 minute, let me, so just pass me a charger. Yeah, it's very low. I'm sorry. Hello. Yeah, sorry for small delay. So these are the heap rules and everything you can see. So the thing is, this program is written really well if it's in a single threaded environment, but it uses p threads. They didn't affect this, they didn't protect all of these global variables. So what happens if one thread basically say one, like if it's a free here, right? So one thread basically after this free, so so what happens is, what I could do is I could malloc something, and when it was supposed to do this scanf part here, scanf here, what happens if I free it, and then I will wait for the scanf didn't input any data, then free it using other thread. Then at that point, at when this is freed, and even this checks get bypassed because it hasn't nulled it out yet. So after this, I wait for some time, free it using this other thread, and write it here. There is a use after free here again, right? So a memory corruption happens here because of the thread usage and them not protecting the global variables. So let's go here. Let's, so the reason for is theory can only get you so far. So let's get practical right now. This is the challenge environment. So we have this challenge, the same baby prime level 9.1 file here. I will create you another tab where we have the exploit here. That level, this is the exploit here. I can give you a code, a walkthrough on that that file as well. So what I'm basically gonna do is, this is the file, and this is the level 9.5 I have renamed here into exploit. When you see it, I basically create two threads here because two connections, two threads are getting created. So what I'm going to do is attempting raise conditional two thread leave. What I basically told you this thing, right? I'm gonna free it one chunk, then I'm gonna print off because I need to use it to get the memory values, what we would say. So I use this here. But if you want to see what I did here, the free the scanf part, it's done here, because what basically R1 did was R1 was doing the send line message and everything. R1 was doing something, thread 2 was doing something. So using both of the threads at the same time. So free 0 basically what it does is free 0 uses thread 1 here. It basically frees it, and scanf basically gives the input, and during the scanf wait part, it basically after the free, it basically sends the value and everything, because at that point this is waiting for the input for the free, and then it free it. So at this point this address is freed already. According to golden rules of dynamic memory allocation, it shouldn't be, but it was freed already. Then we are sending the value. So what happened was, there is this issue called use after free. There is this issue called use after, which happens a lot in browsers. A lot of memory corruption vulnerabilities you see in browsers, Google Chrome and everything that gets reported is part of this vulnerability. What happens is, someone frees it and use the memory again. So there are a lot of inside things, so which is basically super complicated. But I could suggest you resources where you can learn about the C programming stuff, memory concepts and everything inside it. So this is the same exploit here again, the scanner 0 and everything I told you, right? So this is the same thing here. So let's run this challenge. The part of this thing is, we are going to get something called as this thing called flag, which is basically permission denied because we can't access it. But this is a sudo file, this is a setuid file which has root permissions, so this can access it. So basic, but mostly what happens is, race conditions doesn't happen at the very first time. Like, they are a lot of failures because it has to hit the memory at the perfect point and everything. So let's try it. It is trying race conditions again and again. Sometimes it's not working, because you can see here the connection got opened, here it has been closed, because here you can say race failed it, let's try again and everything. So at a point what happened was, race condition was successful. It basically says secret authorized, you win, here is your flag. So let's go to this part as well. So this part, right? So what happens is, you have to leak something called a secret here. Then after this secret, what happened is, this win function gets executed and it will print your flag. So a really good program that is really secure at single threaded environment have really good chance, like it is not secure in multi-threaded environment. So if you are coding, you are changing application development from single threaded to multi-threaded, there are hell a lot of amount of work to do, because you can't use the same thing in both of the places here. Because multi-threaded environment, a lot of care should be taken. Even single threaded environment, if you use signal handlers or anything, be prepared to face a lot of race condition kind of issues. If you use mutex locks, there isn't the issue, or you could write it re and entrant as well. So any questions? And I want to take questions. So let's go for the question scenario right now. So yeah, Q&A. You can ask me anything. Any doubts? Sorry, we can't unmute it. Really sorry. Okay, some people actually processed. Okay, it was for the last thing. So process instance of program thread is the smallest unit of process. Really good. Yeah, that was good. Running, actually, it is a thread who executes. Yeah, that's why it's called thread of execution. That's true. Process has multiple threads. How can we test application for such race condition vulnerability? Yeah, you could check for the global shared resources, like what I said it. Like when you go for a multi-thread application, or a file or application that uses file system, and you have file system access, you can search for race condition vulnerability, time of check and time of use and everything. But there is this question, because like race conditions can be mitigated using mutual exclusion locks in memory. But what happens in file? Because file can be changed. Even there used to be, there will be a single race window almost like any time. So how you can do it? So instead of if I use something called as instead of stat, if I use fstat and checked it, because fstat use something called as file descriptor. Whenever you open a file, you have got this file descriptor, then check for the file system, then check for all of the information regarding the files, and then use it. Whenever you use anything, have a file descriptor handle rather than checking using the file name or accessing via the file system. Because what FD does it basically takes the file contents, use it, and until the end it won't have any changes. So whenever you want to use anything, use it with the file descriptor. It is really useful. Fstat, if I use instead of stat, if I use it fstat, it won't be vulnerable at that point. So any more questions, like two new messages? Do you think AI agents or this? uh, Let me come back again. Do you think AI agents and someone can be able to mitigate and this? No, like no AI agents or ML stuffs, like I believe it is very hard to find race conditions. Like I'm telling you, even I'm the thing is, even through source code review, it's very hard. Training an AI agent to find for race conditions is gonna be a very hard time doing it. I don't think it won't be, but even doing it will be very hard because you can see, right? Because this program looks really secure. Even if you went for any SQL injection vulnerability, you basically know how the program looks like. But when you need to know what are the global variable that getting access, even like I have seen a lot of people when they perform CRUD operations using a database handle and Spring framework or everything during my developer days. I have seen people using database handle every place and trying to access at the same time, which makes it vulnerable. People use this kind of mistake. So uh, I have never seen an AI agent was able to say this is vulnerable to race condition, or any compiler that says use it or anything, because it is not. Because I believe it's a very far cry for anyone to develop something to escape from race conditions. So let's see, maybe if someone pulls it out, it's really good. And there is this, where do you mostly find such bugs? Multi-threaded environment and multi-threaded environment. And if you want to search for privilege escalation bugs, there are even race condition bugs in Apple as well, like privilege escalation vulnerability in Mac OS and everything. There are a lot. Like when you want to find race conditions, you can go for web applications, you can go for desktop applications, you can go for anything. Like even I told you, like even a single threaded environment is not safe if it's you use signal handler functions. And if you go and write a really good application, you need a signal handler. But that signal handler is a double-edged sword as well, because it's gonna give you a race condition as well at a point. You have to develop in a really good way. And people who wants to know where you can learn all of this C programming stuff, there is this really good article called System Programming. This is the place where I learned a lot of C programming. Like you could refer this process, memory allocators and thread. I told you dynamic memory allocation and static memory allocation, right? You can see what is basically this and everything. You can see about p threads here, that what are the p threads I showed and everything, synchronization, deadlock, inter-process communication, everything can be learned from here. I'll just drop a link so you guys can, if you want to know, you could see this, because I like low level stuffs a lot, and this helps me a lot. This, I was able to understand a lot of system internals and system programming from this system programming thing. You could learn a lot from here. So being you being into IoT, so do IoT devices have such vulnerabilities? Yeah, IoT device have such vulnerabilities. Like it's according to what type of IoT device and what type of firmware I get. So this is a bit different. So if it's a full system firmware and it has thread capabilities and everything, I would look for a program that uses this and everything. So, but I have to reverse it. There are a lot of things. So even if you want to find something, if you want to go it in the search, we will find race conditions. If not, try to pick out the the thing that even affects in single thread environment, like buffer overflows, format string. These are the basic bugs like it should be secure from, because buffer overflows, like what I believe is like it is it is not a lot existent these days, but in IoT device there are a lot. It is super critical as well, because if you have a stack based buffer overflow, basically that puts the program at a whole risk, because it basically doesn't crash it, because the data complexity goes into low, and you can basically spawn a shell from remotely if you have a remote buffer overflows or anything. So yeah, then boils down to it. Finally, you could use race condition in a application kind of thing is basically it's a chaining part. Race condition doesn't go basically race condition to a RC or anything. There are some, but not all places, because in memory race condition, what I say is actually in this challenge, what I did is in this lab as well. I used the race condition to make a use after free scenario and exploit it. It was not only race condition that was vulnerable. I used a use after free and race condition, coupled it together and exploited it. So I used both of them here. I'm beginning. I tried phone challenges for memory error, format string raw up to 67, but I'm going which path you have to follow. Web testing, network pen testing, system security, which can land me in a job fast. I can. Um, what I would say is what I followed was my passion. Like I loved memory corruption a lot, and I loved like reversing a lot. So that's why I came into this job and everything. So try to follow your passion and everything. If you want to go into binary exploitation kind of job, like what we do in Payatu and IoT firmware, what we do is we hunt for memory corruption bugs and we do reverse engineer, because this is my passion. Like I have to, I have, I like working here, and also I like working on this domain and everything. So if you, choose your job according to your passion. If you are really good at black box pen testing, web is a really nice place. If you are really good at like going through the C code, or if you like low level programming really well, by IoT security is really well. So if you are good at learning networking, or some really good network concept, or you could go to blue team, everything. There are a lot. So always search job based on your passion, not based on like I'm getting graduated. Always go for, because in the long run, people will be having a job frustration. Like if you don't follow your passion, so follow your passion and land a job there. Basically, this is my passion. I joined it. I know about basic Linux assembly before web pen testing, but I don't have it. I play some CTF also. Do something that will give you a reach. You could give a talk. You could network with a lot of people. You could play CTS. CTS is what got me into this and everything. So this is how I did, and I network with a lot of people, and I have some amazing co-colleagues let me to get a lot of knowledge about this. So these are a lot of ways you could do. Actually, you to already have one doubt. Can you able to reverse the ML models like Navy bias and regression? I have no idea about this. Navy bias and regression. Depending upon because I need to know about what Navi buys and regression is. If I can see what it basically does, I can able to get like what type of program it is and what tools you can use to like reverse engineer this and well. So for learning ASM, you can check out this resource. Yeah, Nanto Detrix is really good for getting started with reverse engineering, beginners.re. And there is also this book called Learning the Art of Exploitation. If you want to get good at C and also want to learn this underlying memory concepts, system programming, and both of them is good. And there is this also, if you want to learn binary exploitation really well, I could suggest you to visit this playlist called Live Overflow, who has a playlist for beginner memory corruption and binary exploitation and everything. It's very hard land in job for pressure. I don't get what you're saying, but it is very hard to land a job as fresher. Yeah, I agree. Like it is true. But if you have a really good profile, and if you have done a lot of work, and if you have got a really good knowledge, and if you really do very well good at interviews, you can basically get a job really well. We have openings as well. You could try for Payatu. We have a red teaming opening and GRC opening as well. You could try for it. We have an amazing team and everything here. So yeah. So any more questions, or is it done? And do people really get all of this really well? Thanks. Yeah, because LinkedIn is hard. Yeah, I get it. Xtrio. Yeah, Xtrio is really well because it was like Live Overflow was also telling you, I mean, how to make career out of phone. How to make career out of phone. You have to choose the job according to it, because like when I came into IoT security, I this reverse engineering mindset I had actually allowed me to escalate, allowed me to land it. Like I am really good at reverse engineering, so I was able to get a lot of concepts really well when I got hired. So be really good at basics, basics programming, basic system internals and everything. It's don't always try for the hard ones, because the fancy ones you read may not be present tomorrow. Anything, please be super good at basics, because even it's a web application or anything, if it's like a web application, become really good at SQL injection, uh, able to read really good easy web code and everything. If it's for my domain, I could basically say you could really learn C programming really well. Need to understand what everything does in the memory and everything. These are the most important things I would say. And we reach to you, LinkedIn. Sure, you could message me on LinkedIn. I will be active. I'm really active there. And thanks for the session, Ajay. Yeah, really thanks. I can play in your team. I think we have an opening for firmware security researcher as well. You can go for payatu.com. We have an you could mail our team as well, or you could apply from there as well. Yeah, we have our job description and everything. If you have a lot of this, you can able to understand it. Thanks for watching. Yeah, thanks. Any good resource for reverse engineering? Uh, yeah, there is this good beginners.re also. That is a good book, like someone mentioned it. Good place to read. Then there is this other thing called as, there is a book for beginners for reverse engineering for baby, or like dummies or something. There is this book as well, which is really good as well. You could refer that. We have a lot of YouTube videos. You could go live overflows channel. You want to learn about IoT products, or like if you want to learn about hardware hacking, you could go stack smashing. We have a lot of we just have to Google it, and we have a lot on YouTube as well. Try to there is this video by Live Overflow who actually uh, where there a lot of security researchers combined, and they basically introduce their channel. You could look upon that video, and from that video you can basically know what this content creator does for the security, and what are the things we can learn from it. It's a really good video. Any good resource program say for Windows API? Windows API, I think Windows API, you could basically go for, I have seen this resource. Let me recollect it. Yeah, I think Windows. I think Microsoft even has its own documentation, I guess. But there are some undocumented APIs as well. If your people are really want to get into malware, there is a place to read undocumented APIs. If you want to go for programming in C for Windows APIs, I would say basically Microsoft. Microsoft has their own guide and resource. It's an official guide actually. It is really good. You should check it out. It has been documented really well. Thank you so much. And current for amazing. Thanks. Thank you, everyone. It has been a really wonderful session, and the questions have been really nice. And if I was really happy, so I was able to interact with a lot of people, and I was able to remove this idea of people that spamming request and like just a spamming request or doing something, doing multiple times the same thing, multiple things at the same time will cause race conditions. It's like I have changed it to like accessing the global resource, and that's I made that change. It was really good. Let I need to have some water. Any good resource for malware development from basics? There is this channel in YouTube. I forgot. It was really good. Maybe link reach me via LinkedIn. Actually, I just saw. I have it in the collection of resources. Maybe I will just get back and I will just tell you. Yeah, Crow. Yeah, Crow is that person. Yeah, he has an hour-long video, I guess, or 30-minute video, I guess. It is animated. It's really funny and everything. You should try Crow. It is really good because I have seen a lot of persons who try Crow. Even my CTF teammates used to tell about this. Like Crow's really good. You should try it and everything. Thanks, Sushant Mane. Like I was about to see it, and you told me. Any other is any good resource for web application pen testing? If you have money, I would say go for Pentester Lab. If you don't have money, I would say go for Ports Figures Lab. If you want to do it dynamically and try it out as everything as well. We have we have a lot of blogs in blogs.payatu.com as well. We have written a lot of good blogs for web application, and then there is this thing as well. Then there is a lot of web application security researchers. We have a lot of blogs from them. We have a lot of content creators. Basically, a lot of people actually like show up in web application pen testing only. Like you have a lot. Like there is this channel I used to like a lot. It is a bit dysfunctional right now. It is called Pwn Function. It will teach you web in a really good way. It in an extreme way. I used to like watch that video, and it is animated really well. Check YouTube videos and blogs from Husky Hacks. Yeah, Husky Hacks is good. Thanks. Which channel? Phone function. There is this channel. I'll just put it up. Phone function. If you want to get into binary exploitation, rather than going to Pico CTS, I will tell you all of you guys to go to this one, Phone.college. It is really good. It is super good. You can learn about Linux as well. Getting started. It's for everyone. If you want to go for intro to cybersecurity, you can see talking, building a web server using assembly language, intercepting communications, access control policy, and everything. I haven't logged in yet. So cryptography, web security, we have everything almost like up to down. We have almost like everything here. What is an intro to cyber? Like it is about web. Try to learn the language, a basic programming language like PHP and everything is fine. Like please don't go like because I see in a lot of people what they do is basically go for Node.js because they think it's a trendy language and everyone it is a good language, and I would say, but if you want to learn something really well or something, it basically start with PHP. From there you could go to fancy based languages, fancy languages like Node.js. If you want to go as a front end developer, I could basically say go from HTML, CSS, normal vanilla JS, then go for Angular JS and everything. Then React, we have React. There are a lot of front end languages as well. So learn programming because programming is very important, because I have seen a lot of misconception among people like with zero programming knowledge you can able to excel really well in cybersecurity. But there are some exceptions because I have seen people who do it as well. But programming is super important because if you know programming, you can able to get what's happening inside and what it should have been inside, like it is. Yeah, even this one, Ragira's method, ironstone.gitbook.io.net. Yeah, it is good. It is good. Ironstone, like I have seen it for one challenge, I guess, like for uh, exploiting over sockets, maybe I guess. Like I saw it very recently. It was a really good raid. Like they used to dub 2, I guess. Like it is really good. You should try it. Any more questions, people? Like regarding race conditions, if you guys have any doubt, you could come back to me so I could like explain it really well. Because if some their doubts on race conditions, I really want to, because at the end of the day, the key takeaway is understanding race condition, spotting race condition if you have a source code review, because that's why I've shown you code and everything. Because before this webinar, even if you think it's spanning multiple requests, after this webinar, I really want you guys to know about like race conditions is this. Like if even give a source code review without any dynamic part, you need to understand like, okay, this is a global variable and this access has not been like there is no logs that has been present here. Semaphores and mutex is kinda same. Like it's like partially same, I would say. Mutex is like basically one person has to get inside, but semaphores like there's let's make it as a construct, a cookie in a jar. So what happens is there is this thing called we have some handler function for sem called basically say man sem. We have some open and some post, we would say. So what happens is when you use you can initiate using some minute, then use some open and some post, some and some wait as well. What happens is in a cookie and jar, if you there are like 10 cookies, you put your hand inside it, take one cookie and everything. Then what happens if 10 cookies have been like used? So basically they so until they refill the cookies, you just wait there, right? So what happens if there is only one cookie there? So that's what some post and some wait do it. So what happens is one person run it, it waits, then other like some the waiting part is like the cookie taking part is basically like some person is already using this resource, so you have to wait for a bit. And then there is this some process like basically putting the cookie back so some person other person can use it. So mutual exclusion lock is like locking it, and some post like a cookie in a jar kind of context, so you could learn this. Capture the file FC by Lakshmi, or it is called bit2j. Where can I find the recording link? So, yeah, you could find the recording link. We would upload this recording in our YouTube channel, Payatu's YouTube channel. You could see there. So, yeah, any more doubts and any misconceptions you have in this topic, or anything related to binary exploitations, or anything related to reverse engineering? Yeah. Or can I conclude it? Like because I was about to. Any
So,
so
guys, regarding the recording links, it will be uploaded on our digital channels. The session is open only for 2 more minutes. If you have any questions, put it in our chat box, post which no questions would be taken.
yeah,
Ajay, please continue.
okay. So I think let's wait for 10 more seconds if someone is typing a message. They are two for fresher opening. Yeah,
So,
we have some openings.
so for careers related stuffs, you can check out our career page, which we have posted in our chat box. And any thing else regarding careers, you can always connect to us. You can always mail your resume or inquiries related to it at hr@payatu.io. I'll just put that up in the chat box.
So okay, let's conclude it. So
I
thanks for
guess,
all of
yeah,
these questions, and
right. Thank you, Ajay, for such a
yeah,
wonderful session. And
and
thank
also
you
thank
for,
you everyone for joining me. And it has been a really good. You guys have been really good and listen to all of this. So thank you for joining and listening to this. Thanks everyone.
thank you guys. Have a great weekend.